Welcome everyone. This is our second official voice talk of the autumn semester 2025 and our first proper talk. And we have Moloud Gholami presenting on acoustic and sociophonetic approaches to voice in Iranian languages. And Moloud is presenting her MA thesis research conducted at Al-Zahra University in Iran. And we are very excited to have Moloud here.
Good morning, everybody. Thank you for having me. I especially grateful to Professor Heina for giving me the opportunity to share my work. Today, I'm going to talk about acoustic and sociophonetic approaches to voice in Iranian languages with a particular focus on voice onset time. Iran has a remarkable level of linguistic diversity. Actually, Persian, also called Farsi, is official language of Iran, but there are over 80 other languages and dialects that are spoken across the country, such as Kurdish, Gilaki, Tati, Talishi, Azeri, as well as non-Iranian languages like Arabic and Turkish. But unfortunately, many of these languages are understudied, and several of them are considered to be endangered. In the UNESCO Interactive Atlas of the World's Language in Danger, in Iran, 25 languages are known to be endangered. Gilaki language, which is I'm going to speak about, is in grade 4, which is severely endangered. Gilaki is a language spoken in Gilan province in Iran, which is situated in northern Iran. The population of Gilan is approximately 2.5 million. Bear in mind that this is a very small province, but it has, in my surroundings, it has 5 distinct languages are spoken here. Gilaki has 3 main varieties: Biapish, Biapas, and Galeshi. And I worked on voice onset time, which is a reliable cue to differentiate between voiced and voiceless consonants. It is a temporal relation in time between the release burst of the stop and the beginning of the glottal pulsing. VOT is a continuum that ranges from negative to positive values, and it is a language-specific parameter, which means that each language shows a specific region on this continuum. These are questions of my research. What is the current state of VOT in voiced and voiceless plosives in Gilaki? Does the Gilaki language exhibit distinct VOT values in the initial and intervocalic positions? What relationship exists between VOT values and the place of articulation in the Gilaki language? How is the sex of speakers related to the VOT values in the Gilaki language? And considering the characteristics of VOT, in which category of language, true voicing or aspirating, does the language Gilaki belongs? These are my material and methodology. I chose 10 participants, 5 male and 5 female. All participants were native speakers of Gilaki, and I made sure that they didn't live for a long period outside the province, so to reduce any effect of other languages or other dialects on speakers. Participants had varying level of education. Their age ranged from 30 to 58 years. A list of 12 isolated Gilaki common words were given to them to read them out loud without any marked intonation. 6 additional words were added at the top and at the end of the list to mitigate the impact of intonation for the beginning and end of the list, and they were eliminated from the data analysis at the end. Out of the total corpus of 360 tokens, 331 tokens were analyzed. The test items for the initial and intervocalic position consist of 6 plosive consonants, including both voiced and voiceless variants, B, P, T, D, K, G, and R consonant were eliminated because we figured out that it is a fricative consonant. The vowel schwa was chosen because of consistency and standardizing this. And for intervocalic position, the consonants were put between these two schwa vowels. And for voicing lead and voicing lag, voicing lead refers to when glottal pulsing starts within the consonantal closure and continues to the release burst of the stop and beyond, resulting in negative VOT values. And these pictures are from my thesis, as you can see in the right picture that shows negative VOT value, and voicing lag occurs when glottal pulsing begins after the release of the burst of the closure, leading to positive VOT values, and it is in the left picture. Actually, voicing lag, it has two subcategories, short lag and long lag. Short lag occurs when VOT values are from 0 up to plus 25 milliseconds, which is the consonant is voiceless unaspirated, and beyond that, or a higher amount of VOT, I mean more than plus 25 milliseconds, will be voiceless aspirated consonant. And this is how I measured the VOT in intervocalic position. And for the results in this session, the main question was if the VOT made any contrast have contrast distinction between voiced and voiceless plosives. As you can see, in initial position, maximum for voiced plosives, maximum VOT value was 25 milliseconds, and for voiceless plosives, minimum VOT value is 20, for which implied to a approximately 1 milliseconds overlap in one data. And for intervocalic position, voiced plosives had minus 37, maximum of minus 37 VOT, and for voiceless plosive, we had 27 milliseconds VOT, which shows about 64 milliseconds gap between these two consonants. After that, we had a Kolmogorov-Smirnov normality test to see if the distribution of the data are normal, which they were not. So we used a non-parametric test of Monvitny. And as you can see, there is a huge significant difference between voiced and voiceless plosives in initial and intervocalic position. So we can say definitely that VOT is a reliable and a strong cue to differentiate between voiced and voiceless plosives in this language. For the position, the results show a significant difference between VOT values for voiceless plosives between the initial and intervocalic position. However, the VOT values for voice plosive does not significantly differ in initial and intervocalic position. Therefore, VOT is a valid cue for differentiating voiceless plosive in the initial and intervocalic position in this language. Regarding the place of articulation, we used Kruskal-Wallis tests indicate that significant difference in VOT value of voiced plosives in the initial position across 3 places of articulation: bilabial, I'm really sorry, bilabial, coronal, and dorsal places of articulation. However, there is a significant difference in VOT value of voiced plosives and voiceless plosives in the intervocalic position. But voiceless in initial position, this was, in the intervocalic, voiceless plosives in the initial position in 3 places of articulation. And to present the mentioned differences more effectively, box plots are used. Purple plots are for male speakers and pinks are for female speakers. Horizontal axis shows positions, initial and intervocalic positions, and places of articulation. And the vertical axis shows the VOT values for each speaker. And as results indicate, all the voiceless plosives actually follow a rule that we can see in prior studies, which the posterior the constriction in the oral cavity, the longer the VOT. And regarding the sex variable, in all cases, female speakers introduced longer VOT than male, but this criteria was significant in voiced plosives in both initial and intervocalic position. And here is a violin plot uh, for, as you can see, purples are again for male speakers and pinks are for female speakers in 3 places of articulation and 2 position, initial and intervocalic. And the last question was, Gilaki is a true voice language or aspirating language? This language employs 2 non-adjacent categories, fully voiced and voiceless aspirated for voice in contrast, which is a rare result because based on results, just Turkish, which is official language of Turkey, and in Swedish, we had 2 non-adjacent category. This is not the case in Persian, but Gilaki used this rule and voiceless aspirated phonetic category as the implementation of the voiced voiceless phonological feature and fully voiced to implement voiceless phonological feature. Negative values on the VOT continuum either have pre-voicing or small positive values or short lag. In the initial position, 83% of voice plosives were produced with pre-voicing and 16% were produced with a short lag. In the intervocalic position, 100% of the data of voice plosives were produced with pre-voicing and no cases of short lag were observed. Therefore, a fully voiced phonetic category is exclusively employed in producing voice plosives in the intervocalic position. And because of that, we need to a further perceptual test so we can say that Gilaki is a true voice or aspirating language, which is in progress. I'm doing that test too. And at the end, VOT in Iranian languages, these languages are surveyed, and Persian, Sansari, Kurdish, and Azeri. In all of these languages, VOT were a very reliable cue to distinguish between 2 different voiced and voiceless consonants. But in Persian and Sansari, VOT sex was not a significant, didn't make any significant difference between VOTs for these consonants, but in Kurdish and Azeri, just like Gilanki, sex made a huge difference between VOT of male and female VOT. And these are references, and thank you so much for your consideration.